All right, so first thing that I said that we do is figure out how to make all these ocean areas no data while keeping all of the land areas 0. Anybody got some suggestions?
So some kind of like nested conditional statement?
Yeah, well, that probably would work. Some kind of nested conditional statement. So maybe we could take the array and say if that array met the criteria, then we could assign it something else. Right? Yeah.
Or you could do an if statement. Could you do an if statement?
An if statement? Yeah, you probably could. However, you couldn't really do that with the, I mean, you could create two different arrays and kind of merge them back together. You could do that. So that's an option. But you'd still need a conditional statement in there. So it'd basically be like nesting them. Anybody think of another one? Let's see if I can implement that real quick. So you're saying nest another where statement right here. Something like, so in array 2, we know that it's a value of 14, right?
Right.
So if it's greater than 75, do this. So that's fine. If it's not greater than 75, we'd have to have something like that. So if it equals 14, what's that? So if it is true, no, if it equals 14, make that like negative 99, else 0. So let's see. So here I'm saying np dot where if the original array is greater than 75, make it 14. If not, then if it's equal to 14, make it negative 99. If not, make it 0. Then I have to change this to negative 99. And that should work, although I'm not totally clear on the syntax. If the nested syntax doesn't work, we can just make it into two separate statements pretty easily, but it should work. It restarted.
What's causing us to do that?
I think it's because I have it open over here. And then once it restarts, sometimes, as he was noting, sometimes it doesn't stop restarting until I also close Python down. Okay. I wonder if now it's corrupted the original data set. I should have saved this as a new example, but okay, so now it's done. Catalog. So here's the one I just did. All right, so these are values of 0. And these are values of no data, and these are the values, and it worked. So that worked. That's good. So we nested an array. One thing that I was thinking of is that, that's not the route I was thinking of going. One thing I was thinking of is change this to a ridiculously high number, a temperature that would never exist, that would be really, really high. And then after doing this math, those would all be the same numbers, but they would be ridiculously high. And since they haven't been converted to zeros, we could figure out what they were and feed that in as the no data value. So what I mean by that is 1,000 would never be a real number, a real temperature, right? Even in Celsius. Of course, we're dealing with ones that were originally 2,000, so that might be, but let's change it to something like that, let's say, some huge number. So I'm changing it to 1 million, okay? So now, let's call this temp 5 or something and say file, save as sample 7. So now what's a million going to be in this equation? Let's just run it once and find out. Not in quotes. So I'm not saving it this time. Oh, then I'm going to delete this. So it's just back to 0. So now, right now, the reason why I'm running this is to figure out what that no data value is going to convert to after it goes through this formula. It's 1818032. So we just give that number here and uncomment these. And this should have the same effect as Ashley's solution, which was a good one. Because it allowed us to kind of experiment with nested conditional statements. Okay, so here's my solution. Looks exactly the same. Does in fact work exactly the same. All right. So both of those solutions will be up there on GitHub. But they both logically work. There's probably other things that would logically work. The secret is that you need to isolate those values and as separate, so they have separate logical flows through the program. But finally, one last thing that I want to show you is that there's a function called asType. So you remember when I just tried to make everything an int and it didn't work? asType is a NumPy function that'll take an entire array and convert it to a different type. So if we wanted to convert it back into integer because it'll create a smaller data set, we can do that. I'll call this, what was the last one? 5. I'll call this 6. And I'll save this. I don't know if I need to save it out as a whole new one, but I will. And then I'll run this guy. And this will save, we'll be able to see it in this. This will save all the numbers out as integer values, so they'll be a lot smaller on disk. We can't actually see that. So these are the integer values. If you hit properties here, it will tell us the size on disk somewhere. Usually the uncompressed size, 3.12 megabytes. And if we choose the float version, it says 6.24 megabytes. So it does make it smaller. Further, if you were to zip it, like if this was a TIFF file, if you were to zip it, a compressed TIFF will zip a lot. It'll compress a lot more than a floating point number. It'll compress more. So not only is it just smaller on disk, it can be compressed even further to be even smaller. All right. Okay, so I think we're good there. All right, so let's go over what the assignment is, and then we'll start thinking about how to do it. Okay. So these should, I didn't talk about this, these should actually be indentions. Okay? So we didn't go over it. Maybe we have some time next week. I'll go over it a little bit. They're built into SciPy. There's this thing called. I'll just go ahead and show you it. There's this thing called convolve. Okay, and this is basically the scientific way to do a neighborhood filter. So a convolution, sometimes they're called convolution filters. So there is a function to do things like calculate slope or just smooth a data set. You're doing neighborhood functions. You can do those in ArcGIS. You can do those in NumPy. The one thing that there aren't a whole lot of is the, how to put it? There it is. One thing there aren't a whole lot of are functions like this, raster to vector conversion and back. So that doesn't really exist in NumPy. Okay, so those are some things that you could rewrite a lot of code, or you could just use ArcGIS. Raster proximity functions. In other words, calculating Euclidean distance or least cost path distance, which we never talked about in this course. We did Euclidean distance last week. Those things are hard to replicate in NumPy, although they could be done, but there's not some tool that exists, or not some, there's no SciPy tool to do that. There is a SciPy tool that will get you close to doing Euclidean distance. But we're not gonna talk about that this week. Just there are some raster GIS functions that would be hard to replicate in NumPy. But almost all the other ones you could do. So we talked about conditional statement, that's a big one. Reclassify is basically doing a bunch of nested conditional statements. We talked about slope, although we didn't demonstrate it, and all the rest of the convolution filters, image processing. There's a bunch of tools for image processing already built into Python. You could do things like we talked about last week, find the edges, things like that. Okay, outside of ArcGIS. All right, so now here's our assignment for today. Our assignment for today is to download the data. I think we might have already done this. It's the same temperature data that we're dealing with already. Good. I almost thought I didn't start the video. Okay, we're going to download that data, and then what we're going to basically do is something very similar to last week's lab, except for we're not going to do a a buffer, Euclidean distance tool. We're just going to take all the temperature data, and we're going to add all the temperature values up using a loop and the eval statement. And then you'll be done. But now you're basically going to do what you did last week, but you're going to do it with NumPy. So you're going to take all the values, you're going to write a loop, and inside of your loop, you're going to convert every single list item, every single file, temp1, temp2, temp3, temp4, temp5, temp6, convert all those into NumPy arrays. Okay? And then, once they're NumPy arrays, you're going to add them all up. You can add them all up. There is a way to do it without the eval statement now, but it's pretty, it would be a little bit more complicated. I suggest you still just use the eval statement. So you're going to have each NumPy array, and all you need to do is add them together, like array plus array plus array plus array. Sounds like I'm saying hooray, hooray. But so you need something like that. But you won't be able. You have the same problem here, where you won't be able to build this dynamically without using the eval statement as we did last week. Okay. All right. There is, so I'm just going to tell you really quickly, there is a way to do it without the eval statement now. What you'd have to do, Python, in NumPy, there is a function called sum. And it'll allow you to sum elements of an array. By default, it'll take all the elements of an array and squish them together and give you the sum of every element in an array. Alternatively, it will allow you to sum across one of two dimensions, the rows or the columns. So what you have to do is you'd have to read in all these temperature arrays, convert them using the resize. We did it already in so file open, sample 1. So this line of code right here, the shape. So you convert them all to one-dimensional arrays that are just really, really long. Then you basically stack them into a two-dimensional array and sum this way, and then convert it back into a two-dimensional array. So you can do it that way. Maybe I'll post an example on how to do it, but it involves like changing the array size. So we'll leave that for now. Just do it the same way as last week, so it'll match last week's pretty well. And then what I want you to do is notice how much faster that it runs, because it's going to run faster. So that's one of the utilities for using NumPy, is that you're keeping everything in memory. So you need a little bit more memory to run it, but the trade-off is it's going to run really, really fast, because it's just going to take all these values and squish them together all in memory and output the number, and it'll work well. Okay. So what we want to do is add them all up and divide by the total. So I know that it's not a true average, because really the monthly average for March is a composite of all those 30 days. So we already averaged it once, but we're taking the average of those years and coming up with an average monthly temperature. And that, it really is an average monthly temperature, but it's not the average yearly temperature. So it's an average of the average daily temperature. All right. Okay. So let's kind of set the program up. File, save as. We'll call this Raber underscore 11_1.py. And then for fun, I'm going to open up, because I'm going to be able to steal some code from last week's lab. So I'm going to open up 10, and all this data right here, I'm just going to go over here and steal it. But I don't need cell size, I don't need workspace. I'm going to leave override output in there. I don't even need to check out an extension. Spatial Analyst is the most expensive extension. It's almost as much as the base price for ArcMap, for just the cheapest ArcMap you can get. So, you know, in some cases it's great to be able to have. I've also got to import just plain old ArcPy. I don't even think I need these for today. This is really the only, in fact, I don't even need that line. It's not list feature classes. It's called list rasters, I think. Oh, sorry. I do need the, well, I don't really need it, but I do need to set the workspace. It's gonna help if I do. Pretty sure it's called list rasters. I will look and see if I'm right. ArcPy list rasters. Yes, that's what it's called. But now my rasters are in here. So I'll make this. This is what I meant. If we could name that temp underscore F, it wouldn't work. Okay, feature classes. So this is how we would loop through our rasters and get each one of them. Make sure that's working. Yep. So these are all the rasters. Does it matter if the order of the rasters for the math that we're trying to do? No, it doesn't. If there was a reason, like we were doing temporal modeling, which I think I've used the same data set for before, if we were doing temporal modeling, we would have to find a way to request temp 1, temp 9 in order, but it doesn't matter. We're not doing that. So we're just taking all these numbers and adding them up. So in here, we need to put some code that will convert each of these into an NumPy array. So the first thing we need to do is list of arrays equals. So we're going to put each array into a list. We're going to build a list of all the arrays. So inside here, we need to do something like convert raster into NumPy array, store NumPy array in list. Okay. And then outside the loop, we just need to use an eval statement to add up values in array. And then finally, save output array using NumPy, what's it called? Oh, that's last week's. Open. NumPy2 array. Using NumPy2 array raster. So you'll have a statement in here that'll be something like, you have to build the eval statement first. So let's say build eval statement. And it'll be something like this. For, that'll be the hardest part, I think, actually, of the lab. I already closed it up, didn't I? Open. SPA, or temp, SPA, lab 11, no 10, example. So you'll have a thing like this. It's not a for statement, sorry, something like this. So you have to build the eval statement, that'll be like that, and this will be like this. So you're joining your output list. Oh, that'll be a little bit tricky. So these are just items in the list. Yeah. So there'll just be like list 1, list 2, list item 3, list item 4. So they'll all look like this is the statement that we want to create. Because the red doesn't show up, does it? It's because the blue is going out. I'm just going to go like that. It's actually this is actually red. Yeah, that's why it's crazy. Okay, so yeah, this that says convert raster. Oh, that works. Oh, you mean this pale yellow? Because red actually works. It's the green that doesn't work. Yeah, red works. Okay, so I'll leave that commented out. Let's see if I can. Options. Oh, it's not. That's not the problem. It's the green. I'm gonna make it a deep blue. All right. So, yeah, it's just on my screen that appears blue. Okay. So this statement right here has to actually look like this: list of arrays 0, list of array 1. Okay. I will. Yeah. All right. I think the best way to do this is to go back to the interpreter for a second. So, in order to build a statement like this, if I say, whoops, if I say something like, whoops, okay, if I say something like x equals range 0, comma 12, I get something that looks like that, right? So if I did something like this, oh, x is a string. No, x isn't a name. Oh. Hold on. So I need to convert. I'm just going to write this command, and you'll have it in there so it'll work better. Convert all items in list to string in place. That's floats. Yeah. Oops. Okay. So I'm just going to take a shortcut. I could write a list that would do this, but I mean I could write a, yeah, that'll work. Okay. Okay. Oh, okay. All right, that's not quite right, but we're on the right track. So what I'm trying to do is get each of these values into there, so that it goes list of arrays 1, 2 with the pluses in between. So let's go ahead and convert this to a small script so that we can test it while we're building it. So I need this line, and I need this line, and then I just need this line right here, but I need to change that. So I'm trying to build this eval statement up. I know this looks a little bit convoluted. I'm going to save this. Actually, I'm just going to save this here. This is just going to be a test because I'm going to throw that into. Actually, make this a little bit smaller. Okay, that works. So all we need to do is say statement equals just like we had to do for the last week's statement. And that should work. That did not, oh, I just want to print it. Didn't spell right. Okay, so see, oh, that doesn't look right at all. This needs to be plus. So what I'm trying to do is build that eval statement, and I think that'll work. I don't know why that last one even ran. Run. Yep. Okay, so that works. See how now it's going to be list of arrays 0 plus list of arrays 1 all the way through, and it's going to give us each item in that array. So all I have to do is copy this back over, and then I'll leave it in the example. You might have been able to do that, but I'm just gonna make that there. So these lines are already built for you. So all you need to do is first convert the raster in an NumPy array. You can do that. That's an example. That's in the example. Then you need to store that NumPy array into a list. How do you do that? How do you add that NumPy array into this list of arrays? Append, exactly. We've done that several times this week. So you have list of arrays dot append, and then whatever you named this NumPy array. And it's going to be named the same thing each time through the loop, and that's fine. So you're going to call this like current array equals, and then you're going to feed it the value. It's going to be this line right here. Oh, file. Not even in the right place anymore. Maybe if I open from here. Yep. Okay. So like, you're going to have a line that looks like this, raster to NumPy array. appropriate no data value to use. But you're going to have that line right here where you're converting it to an NumPy array. Then you're going to store that NumPy array in the list, and then you're going to just do that over and over. 12, it's going to go through, every time it's going to do that, it's going to go through, and we know that this number is going to be 12 because there's 12 in the list. But how can we generalize that? Oh, we could actually do something like this. Remember how we can ask an array for its length? I think it is len. Let's test that because I wouldn't want that to fail later. X equals range 0, 12, len x. Oops. No, it's len x. That's it. Now this won't fail later. Len. All right. So now this is generalized. So this will be 12. This will value to 12 this time. But now it'll, however big this list got, this will always be the same value. All right. So your output array here is going to be the addition of all these arrays. You still need to divide it. So I should put that as another divide output array by 12 to get answer new answer. Okay. Anybody have any questions about, kind of like how you should fill out everything under here? I'm pretty sure that the way I've set this up is there's a one-to-one relationship right here between lines of code and my comments. So, in other words, convert raster in an NumPy array only needs one line. Store number array in list, it only needs one line, and actually pointed out it's going to be .append. Okay? That's all fine. Divide output array by 12 to get a new answer array. I didn't spell answer array, but that still only needs one line. It'll be something like answer array equals output array divided by 12. That'll work. Save the output array as using NumPy array to raster. That'll be one line. Actually, that'll be two lines because you'll use NumPy raster to build the raster, and then you'll use the save command. So I could change this to save or convert answer array to and then save to file finally. Okay. So yeah, there is a one-to-one relationship here between lines of code and things that you need to add to get them to work. All right. Now, so basically, you need to get this to work. You'll get full credit if your no data areas remain no data areas. So you need to find a way, and that's why we practiced it. Find a way for your no data areas to stay no data areas in the output. Also, you won't get full credit. So these are lines you need to actually get the program to run. Okay, but you do need to add a few more lines. You also need to add all the lines that will allow you to reference the data correctly. So if you go back to look here in example 8, basically you need to get your lower left, your cell size values set up here. So you need to add those lines where we create those. So you need to add those lines in here to get it to work right. So again, you could pull that from here, but in order to get full credit, you need to make sure your no data values stay no data values, and there won't be any pockets of no data values that you accidentally created because you used a value that was in the range. All right. I think we should be good. All right. Save that. So that's the example. And then when I stop the recording, actually it takes about 10 minutes to record it out to disk. Stop the recording, this will be up online, but it'll take about 10 minutes. Anybody have any questions before I do that? All right. So my oldest son is in a computer science class. I know this isn't a computer science class, but I spent he's learning C++. I spent like 2 hours last night with him. I don't know C++, but trying to work through a thing, and finally he's like, "Oh, I figured it out." So he figured it out, but we had the code up on both of our screens. So anyway, if you need help, let me know, because I do know Python. I can get through this, but I know we're leaving this a little bit more incomplete than we have in the last few weeks, but we're getting more toward the end. You could actually condense all of this if you really wanted to. You could put all of that inside of this. But you won't. Sometimes I like breaking things up. All right, I'll go ahead and stop the video if there are any questions right now. And then it'll take about 10 minutes and everything will be updated up on